Astronomy pulls at our curiosity and brings the most interesting and diverse people together. Just some pictures here from our club. So this is a story of where astronomy kind of took me and my students and where it kind of brought us to. Okay, so the story starts with a SIC, and the SIC stands for School Initiated Course. Now this was done probably like 9 or 10 years ago with another teacher and colleague and friend of mine. And, whoopsie, too far ahead. Come back. There was a leg. Okay, I'm just not going to touch anything. That'll work. So this SIC, I'll keep talking, it was initially started by Rob Edwards, a good colleague of mine, and we both kind of knew that astronomy in terms of curriculum in schools kind of stops at grade 9. And a lot of the time, teachers either don't have the resources, the time, and the curriculum in grade 9 is packed full of other awesome stuff to do. But we both knew that astronomy, so the unit in astronomy in grade 9 is often left out, or very little of it is even covered, unfortunately. But both of us knew that astronomy is deeply connected to all sciences, with biology, with chemistry, with physics, and including history. It's one of the oldest sciences, after all. And so we started this SIC, and he initiated with his school, and then he brought it to me and said, why don't you start an astronomy course at your school? And I said, yeah, absolutely, why not? So with every astronomy course, in this case our course, there's always kind of a star project stuff. And the star project, if you read a little bit in here, started with the remote telescope. Now this in our backyards, this is kind of the it's Astronomy Without Borders part. It's actually, there it goes. Next slide. This telescope is in Australia. So completely around the world, we got in touch with this gentleman here. This is Dr. David McKinnon, who lives and works in Australia. He's an astronomy professor and educator. And he built this telescope, bought it and built the observatory, and then started to do school outreach with it. This was, I thought, one of the coolest projects to do. And so what he does, this telescope is actually remotely controlled. So he has the setup at his place. I'll show you the website here. There it goes. So this is the official website of CSU, which stands for the Charles Strutt University Remote Telescope here. So he kind of worked it from his university as well. So what happens here is he has the telescope built in his backyard, and then he started to outreach at different schools around the world and in Canada. And at the time, I think there's only 3 teachers in Canada who were talking with David and actively using this, myself, Rob, and another gentleman from Toronto. So with this telescope, what happens, how we set this up. So 9 a.m. our time, I'm feverishly setting up the computer, and it's around 1 or 2 a.m. in Australia, and Dr. David McKinnon is just getting up with his tea and setting up his telescope for us. Next slide, there we go. So this is kind of the little setup here of how it works. So my students would crowd into this computer lab. We did some previous work beforehand. So beforehand, the students would go on the wonderful program called Stellarium, which is at the right price to use for school, free. So the students went on Stellarium. We found out where his observatory was. We got the GPS kind of coordinates, and then the students would research what objects to take pictures of. We would create a list, because we only have about 1 hour of time on this telescope in Australia, so we gotta bang, 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 one after the other, all the pictures we want to take, the objects we want to research. So the students sent off the list. Luckily for them, David kind of takes the list and goes, no, yes, no, and kind of edits it for us. So on the day that I'm setting up the cameras and the Skype equipment, and hoping that it's clear outside, he has the list and he's ready to go. So the students would go in there. We have one screen set up so they could actually see his remote telescope. So you actually logged in to his telescope, and the students had the opportunity to like touch, the keyboard, and all of a sudden, around the world, this telescope moves, and they have made it move. And then you have Dr. David McKinnon, so when you take an image, it might take a couple minutes to actually expose the image. And then he talks with the students and gets them to ask questions, and how cool is it to have a professional astronomer there to answer all the questions that sometimes I can't answer. Ask him. So the students would take different images, so in groups they would research this and start taking images. So we had a screen up of the remote telescope, so the actual kind of like a CSU deal, up there, and then we would have him on Skype and have another picture of the dome. So there was a camera inside the dome. You could watch Dr. David McKinnon go from the host he was Skyping to us, run into the dome if there was issues or problems, and come back out. So it was kind of unique. A unique experience for the students. So the next slide here talks about what happened when we got the images back, how they actually did. So this is really cool. You don't have to read every little part up there. I don't expect anyone to see that, but this was the project here. So the idea here was to research your object, figure out what it is, how it got there, and when you get the image back, it just looks like a whole lot of nothing, kind of a black dot. And we used a bit of a primitive program called Star MX5 to start editing the images we got, again, at the right price, free. But it was a little bit tedious, because the students and I discovered that when you go to actually edit your picture and try to draw out the image in it, there's no backspace button to undo any changes, so that got a little tedious. But this is what they got. So they would take an image, it didn't look like anything. They had to do the same thing a lot of the astrophotographers in the club get to do, which is reduce the noise and mess with contrast and do different things. There's a whole bunch of different things within Star MX5, the program, like power law stretches to try to balance the light and black in the image to finally get to what you want to see, the galaxy here, NGC 1042. Here's another example, the Orion Nebula here. So we were taking pictures of the moon, of Orion nebulas, of galaxies, of all different kinds of different objects. And this is one of them here that you start off with not much, and then slowly the students would get the whole kind of contrast. And the students learned about exposure times, overlighting things. So you could take an image of this nebula here and get it washed out light here, but you could get the wisp in behind it, or you would get the stars in here nice, and you wouldn't get anything outside of here. So the students were slowly learning. At one point, the students came to me and said, well, actually, I came to them and I said, do you guys want to present what you've done? And they kind of looked at me, terrified. Okay, Miss Misner, we'll do it. So somehow these students came to an RASC meeting in Winnipeg and presented what they did, what I thought was pretty brave of these particular students. I had about 27 in the class, so this was only a small piece of the students that actually came. So they came to the RASC and they discussed their project, what they did, how did they do it. And then right after this particular presentation, the students looked at me and said, oh, Miss Misner, can we start a club? I said, yeah, absolutely. Yes, you can. So afterwards, we decided to start a club, which I'm going to talk about a little bit later on here. But these are some of the students I teach here. These are the girls. But we discovered, at least with teaching a brand new course like this, that not every student has an app for science. Fair enough. Where would we be without art and music and Shakespeare? I love this picture. So where would we be without those things? And it's okay, not every student has to be super excited and want to be the next little Bill Nye up there. So how do you get students excited about science at 9 a.m. in the morning when you, or at least walk away with an appreciation of science? They don't have to be scientists. But my goal in my courses is the students walk away being science literate and have an appreciation for it. So how do you do that? I discovered at 9 a.m. in the morning with grade 9s, blow stuff up. works really well to get them excited. But this is great, like for chemistry, biology, even physics one time. Blowing stuff up is awesome. But when it comes to astronomy, show them pretty pictures. So the next thing was not just pretty pictures, was get them actually doing colored images here. So David McKinnon left his position at Charles Sturt University to do another thing at the beginning of September. And I went, oh, what do you mean you're leaving? What do I do? You were the star show. So with a few connections, I got on with this thing here. This is the RASC Cumberland Observatory Global Network of Telescopes. So we took the idea of doing this astrophotography and brought it one step further into colored images. And this is, blew my mind that these telescopes, there was 12 telescopes around the world. If you look on the website now, there's actually 2 more places in Tibet and Spain. They're setting up more telescopes. So these telescopes range from, what was it here? About 0.4 meters. They have 9 1-meter telescopes, and they have a couple 2-meter telescopes here. And this is used for both public education and research. So actually, like astronomers use these things, not just for high school. And last year, we were so fortunate, we got to take pictures from Sidey Springs, Australia. And the second time around, we started to take pictures in Sutherland in South Africa. So this was a totally different experience from David McKinnon. We researched the images just like David McKinnon, but when we submitted them, there was no one else kind of critiquing what we did. You just had to kind of hope it all works out. So you typed everything into a computer here on the telescope, and it kind of pops back out at you. So when you take images with these telescopes, they take it in filters. So instead of black and white, we are now able to use color. And so when we took the first images, we did blue, green, and red. So we did these filters in here. So the students would get back an image, similar to this one coming up here. And so they would get 3 images, and they would have to actually put all the images together to create a beautiful colored image. So we only had, I think, the first few, the green, the red, and the blue here, to put together some really amazing images here. So these are a few pictures coming up here of what the students were able to accomplish. And this was taken with a 1-meter telescope. So this is, it almost looks better on the screen here. So NGC 2068 here, you get some wisps and some really nice nebulas coming out. So we were super excited to get this. And the students, I was amazed how fast they picked this up and how fast they were able to put the pictures together. There's another one here, NGC 2004, an open cluster of stars here. If you look really closely, you can probably tell they're a little off a little bit. So it was some trial and error with some of these ones here. This is pretty cool. So the next one, we took a couple of pictures of some galaxies here, NGC 1291, the ring galaxy. You can start to see a little bit of bars. You might be able to see a little bit of it there. So this is the last one here I'll show you, NGC 138098, the galaxy. You can maybe see some little wisp around here too in the core of the galaxy. There are some pretty impressive images the students were getting. So they ran through the colored images really fast. So we decided to take this one step further. And actually there's a component of these telescopes you can use to do actual research with it. So we tried our hand in research. We kind of dove into it head first. This was a trial thing. So what the telescope did, or what the program does, they can give you a picture of a globular cluster, an open cluster of stars. And the idea is to analyze all the stars in the cluster. So we split it up into kind of 4 quadrants here. Yeah, and so the students were in groups. They all got little sections, and they had to analyze the light of the stars. And again, they had 3 different pictures here. So they were working with blue light, blue, green, red. And they had to analyze it. This is a crazy picture of the Excel file of it all, but just to make it look really messy and crazy. I'll go back a slide. There we go. So we had to use different programs here to use this one here. We were using Photoshop, GIMP, the cheap version of Photoshop, Kyle, and some other programs to do it. with it. So this was our crazy Sprite Sheet that they gave us to do. So you can see how tedious we had to go through every little filter and analyze all the stars. And we got halfway through and realized, oh wait, we didn't get the XY coordinates of where the actual stars are in the picture. Go back, do it again, go back. So the students were learning quite a bit. We're getting frustrated, each one. So this was kind of the next step here. So this is some of the data that we were getting back. This was just the trial run. We didn't actually get a chance to do serious research. That might be the next step beyond this part here. So you can totally see this is the actual line of an HR diagram, which is pretty cool because the kids get to analyze and actually create their own HR diagram from scratch. But these stars should be really over here, so something's terribly wrong with the data, or just how we analyze the data. So it's still a work in progress, but I guess the cool thing here is that the students learned a little bit of the process of science. They learned that what they wanted to know was not just a Google search to get the answers right away. They learned that science takes time. It starts and stops in small fits and spurts and excitement. And sometimes it takes a lot of patience. The students learned from David McKinnon that when we went out to do CSU, the morning, like 9 a.m. in the morning, I have to post a sign going, it's cloudy in Australia. It's raining. And then one night we were halfway through our session. We were so excited getting all these images, and something wasn't right. The wind would blow the telescope. The images would be blurred. And then he would run back into the observatory and tripped over a wire. Telescope goes down, session's over. You can't restart it. We only have an hour, and it's 2 a.m. in the morning, so he's really tired. And that's it. So the students learned that this kind of process of science and trial and error here, and of how it works. So it was pretty cool. So from this experience here, the students, the class that I was working with, like I said, wanted to start a club. So they wanted to take it even further of where astronomy will take you. So, there you go. So those kids made up this part here called the Astronomy My Club here. And together through this club, we went through not only the course, but we took them observing in many different places to learn the night sky. It's one thing to kind of stay in the classroom and do all this great stuff, but learning doesn't necessarily just take place in the classroom. You gotta go outside sometimes with this stuff. So these are just a few pictures of us goofing around here. All right. So astronomy, at least that we experienced in our school, started to bring students together that wouldn't necessarily kind of hang out together in one, and kind of brought us under the same sky. So thank you very much. Are there any questions?
Okay, my name is Richard Gibbons, and I'm from London, and years ago I lived in Kitchener-Waterloo, and I went to an all-boys school there, and we learned in high school, they taught us how to do the science, and they taught us how to carry out the experiments, whether it's in chemistry or physics, and we knew a lot about chlorophyll, what a lot of adults don't, and what its role is. So that's very good. I'm very impressed with the way, but I'd like you to elaborate, for example, in a classroom or in your little laboratory, how you would teach the kids to do science.
Science in general, or the astronomy?
The approach of getting them to do experiments so they understand the processes of science. Whether it's I think that'd be best. Is that basically what you're doing?
Yeah, absolutely. Actually, to get the kids to understand the process of science, we started, and it's a grade 9, we try to do kind of a mandatory grade 9 science fair. This hasn't happened at Maples for a long time, so we kind of pushed it for us. So all the science classes, all the grade 9 teachers, we gave them resources and researched it and got in touch with the science fair people in Manitoba, and got the resources in there to help the teachers kind of go through the processes of science. So start with the question, start with the problem, go from there. Okay, how with the question, how are you going to research it? What do you want to find out? How do you do it? And then we slowly went from there.
This was a very good talk, and I want to encourage you to continue doing that. But just one little thing for us people who are maybe a little shy when it comes to computers. Do you plan to, publish anything, sort of kind of almost, show us sort of the direction, maybe?
In terms of the science, like the last few slides that dealt with kind of research, or?
No, I'm dealing more
just
with getting, like, how do you get the time on the computer, and what do you type in to get the time, that sort of thing.
There is material out there already kind of published by the people who did this. I got in touch from David McKinnon. He was also working on a project with another gentleman to create this stuff, so it kind of stemmed from his circle of astronomy there. Yeah, so there is, to answer your question, there is material out there that would help somebody, like, step by step go through how to submit images, how to process, and how to do all that, like the big Excel file that looks monstrosity, that looks crazy. There is like a step-by-step procedure, even to how to do the images. They were like step-by-step. Yeah.
Good. Okay. Thank you.
We're over time.